Energy storage is one of the biggest challenges currently facing the renewable sector. Key to its growth and development is the ability to store the energy it generates until it is needed. That is why this renewable energy generation and storage breakthrough is so significant. It is a game changer. Coastal Protection Engineering has come up with an exciting new way to generate and store renewable energy, combining the principles of pump hydro storage, hydroelectricity and gravitational force, called the Seawater Exchange and Storage System. Its ocean hydro technology breakthrough harnesses the power of seawater and tides using an innovative multifunctional system which is more efficient, more cost-effective and more sustainable than current technology, and also protects against coastal erosion. A conventional pump hydro storage system is a tried and tested way to store and release hydroelectricity using a two-stage process. Process 1 involves two reservoirs, a lower reservoir and an upper one. You buy in energy when demand is low, use it to pump water to the upper reservoir through a reversible turbine where it's stored until needed. In this example, the lower reservoir level is reduced by 8 metres and the upper reservoir is increased by the same amount. Process 2 kicks off when demand for energy is high. The water is discharged to the lower reservoir through the reversible turbine, generating hydroelectricity. The upper and lower reservoir water levels equalise and the cycle can begin again. Storage conversion loss averages around 20% per cycle. Now, compare this with the patented technology of the innovative Seawater Exchange and Storage System. The circular structure houses a lower reservoir with, let's say, a capacity of half a kilometre squared, and a number of upper reservoirs, which, taken together, have the same overall capacity. To all intents and purposes, the capacity of the ocean reservoir is unlimited. In this example, the structure is 10 metres above low tide level, but it could be lower or higher, depending on storage requirements. There are 4 turbine housings, each with 2 sets of turbines. The Seawater Exchange and Storage System uses a 4-stage process. Here's how it works. Process 1 involves 2 reservoirs, just like conventional pump hydro storage. Just as before, you buy in energy when demand is low. Seawater is pumped from the lower reservoir to the upper reservoir through the reversible turbine and stored until needed. The lower reservoir is reduced in this example by 8 metres lower than the surrounding sea level, and the upper reservoir is increased by the same amount. Process 2 introduces a new stage, refilling the lower reservoir. The bidirectional turbine from the ocean reservoir opens and seawater flows into the lower reservoir, generating hydroelectricity until their levels equalise. Process 3 sees stored seawater released from the upper reservoir to the lower reservoir through the reversible turbine, generating hydroelectricity until the lower reservoir is 2 metres. Process 4 then begins. At 2 metres, the bidirectional turbine opens and the remaining water is released into the ocean, generating hydroelectricity until all the reservoir levels are equal. Process 2 yields almost a 100% net energy gain by using the ocean as an additional reservoir. Energy produced by Process 4 more than compensates for any storage conversion losses at Process 3. A high tide scenario is an opportunity to boost energy production. In the UK, a high tide can increase the ocean level from between half a metre to up to 15 metres. Let's say the ocean level rises by 4 metres at high tide. This increases energy production proportionately during processes 2, 3 and 4 as the water moves around the reservoirs. To summarise the benefits of the Seawater Exchange and Storage System, or SESS. It allows flexibility of energy generation, storage and release with minimal conversion loss. Storage capacity and energy generation can be increased to match demand. High tides can be used to generate additional hydroelectricity. It makes renewable energy supply reliable, affordable and sustainable. Multiple SESS units can be joined together to form an ecological artificial barrier reef, which also provides coastal protection. The artificial barrier reef can provide a whole host of other benefits on sea and on adjacent land, including land reclamation, which allows it to be used for sustainable farming and leisure.